In this lesson, we'll talk about increasing and decreasing functions, and we'll address the functions that we call continuous, which are the types of functions that we'll be working with in Pure Mathematics 1. To give an example of continuous functions and functions that are not continuous, we will take a look at the graph of two functions. One is y equals ax cubed plus bx squared plus cx plus d, where a is a non-negative real number, and this is what they generally look like, and one is y equals the integer part of x. As we can see, the second graph has what we would call jumps in it, and the first one doesn't. The first one, these types of functions, are the types of functions we'll be working with, and we call them continuous, whereas the ones on the right, we will call them discontinuous, or say that they are not continuous functions. So we'll be working with the former. So let's see then what increasing and decreasing functions mean. Now we have the case of two functions. The graph of one is the red one on the left and the blue one on the right. We will define a domain for our functions, an interval in which we are working. We'll be working in an interval a to b, meaning that x will be less than or equal to b, greater than or equal to a, where a and b are two real numbers, and a is definitely less than b. We do this because the graph of a function may have many variations, so we want to see in certain intervals if it increases or decreases. So on the left, we've mapped out this interval from a to b, and we have the values corresponding to it, f of a and f of b. So we'll study whether the function is increasing or decreasing in certain intervals. A graph such as the one that we see on the left, we will say that it is decreasing. But how can we express this algebraically? We'll choose two random variables within this interval, x1 and x2. And we will choose x1 to be less than x2, and both of them within the interval within a and b. To x1 and x2 correspond f of x1 and f of x2. And in the case of a decreasing function, we will see that if f x1 is less than x2, that means that f of x1 will actually be greater than f of x2. We will say that when this happens, the function is decreasing over the interval from a to b. On the right, if we choose two random values x1 and x2 within our interval, we have again chosen x1 to be less than x2, and within the interval from a to b, we will see that f of x1 is also less than f of x2. So if x1 is less than x2, then f of x1 is less than f of x2. And we will say that these types of functions are increasing. So let's revise just one more time. If for x1 is less than x2, we get that f of x1 is greater than f of x2, that means that the function is decreasing over the interval from a to b. If x1 is less than x2 implies f of x1 is also less than f of x2, then we say that f is increasing over the interval from a to b. Does this mean that all functions or the graphs are either increasing or decreasing? It depends on the interval. Let's take the case of the function f of x equals x squared. which we see here on the left. The graph is a parabola. Depending on the intervals that we choose, we can say that this function is increasing or decreasing. As we can see on the graph, part of it is decreasing, part of it is increasing. If we were to choose, for example, the interval -2 and 2, we cannot say that this function is neither increasing nor decreasing on this interval. And why? Well, the definition doesn't work. If we take, for instance, x1 to be -2 and x2 to be 0, then f of x1 will be f of -2, which is 4, and f of x2 will be f of 0, which is 0. So what we have is for x1 less than x2, this implies that f of x1 is greater than f of x2. So it would imply that our function is decreasing. But were we to choose x1 is equal to 0 and x2 is equal to 2, which would imply x1 is less than x2, when we do f of x1 we get 0. When we do f of x2, that's f of 2, which is 4. So we get that f of x1 is less than f of x2. But this would mean that for x1 less than x2, we get f of x1 is less than f of x2, which would mean that our function is decreasing. So we would have a function that is both increasing and decreasing in the same interval. It is exactly what we see here. It neither increases nor decreases across the interval -2, 2. It does both. For instance, in the interval -2, 0, f is decreasing. But for x between 0 and 2, we will say that the function f of x is increasing. So we say it's increasing when x is between 0 and 2. So basically, to study whether a function is increasing or decreasing, it is also important to study the interval over which we are looking at the graph. In the next lesson, we will see how this connects to the sign of the first derivative. See you there.